Alright folks, today's a good day because I've got a package from DIY Recording. Let's open it up and find out what we got. What is happening, fellow nerds? So a couple months ago, DIY Recording, based out of Philly in the United States, announced that they were going to be doing their own Neve 1073 clone. And that got me pretty excited because I've done some of their kits and I love being able to build gear as opposed to buying it if given the chance. So let's see what we got going on here. Oh, and full disclosure, this is by no means a how-to. This is just a video documenting me opening it up, seeing the kit. Especially since it's new, it might be helpful for some people to see what's going on, or maybe if it's like their first adventure into building their own gear. So let's dive in. Alrighty, at the desk, let's tear into this thing. All right, now we're down to the actual box. Very cool. Nice packaging. First things first, we got the operation manual. I guess we'll see if this is just working it or it's actually building it. Schematics. I don't know how to read those, but it looks cool. Okay, just a basic operation manual. Replacement parts, that's pretty nice actually, if anything goes wrong. And I think the actual build guide is online. Ooh, this is a nice heavy box here, got the transformers. And I believe this has 2 Carnhill transformers, which as far as I can understand is the closest thing to the original that you can get. Oh yeah, look at this bad boy. There's a lot of your magic in the sound right there. Not all of it, but a big part. And then this guy, I believe, is also a Carnhill, but a little bit smaller. Actually, a good bit smaller, if I'm honest. There he is. Very cool. Looks like some sort of interface board for this. Well, those transformers are pretty cool. Let's see what we got next. Got a nice looking faceplate here. Ooh, really smooth. Build quality on this seems nice. There's no burrs or anything. Paint looks good. Another factor why I wanted to try this one is it's got the DI built in, and as a bass and keyboard player, I can be using the DI a lot. I know a lot of the DIY 1073s have them, like the Sound Sculptor, and I'm sure there are more, but that was one of the deciding factors for me. Got the main PCB, and in case you didn't already know, this is for a 500 series, so there are our pins right there for power and inputs, outputs. Got a big area for that chunky transformer. Cool stuff. All right, now we're into the meat and potatoes bag here. Imagine this will be a lot of the resistors and capacitors, all your classic stuff, and the rest of the chassis, of course. Metal chassis. Again, nice build quality. Everything is smooth, no rough edges. Feels solid. Yeah, from here, these are just individual components and cables and stuff. I probably don't need to tear this down too much. It'll all get exposed during the actual build. But everything's here, it's in bags separated, which is really nice. So what I'll do next is I'll pull up the build manual online and just make sure I have everything I need, sort things out that I need to, like the resistors, get everything organized, ready to roll before I start soldering, so I'm not hunting for parts as I go. Let's check out the build guide. All right, I'm skimming through the directions now, and everything seems pretty straightforward. There aren't any like crazy extra steps or exotic tools that you need. The only thing that is somewhat new to me is using REW to do a little calibration and testing on this, but they've got a YouTube video laying everything out, and REW is some pretty simple software. So I think this should be a pretty smooth build. Everything's really thought out. And one really cool thing that DIY recording does that I haven't seen anyone else do is this interactive build map. It's got the circuit board laid out, as you can see, and they've got everything sorted out by bag, so you can, you know, start with like bag number 1, and it's got all the parts listed in there. Then I think it might even fill it out as you go, but I'll find out. Let's check it out. All right, with that said, let's jump right in on bag number 1, which is the power supply and miscellaneous other things. So we'll pull out bag number 1. All right, here we go. Some of these bags also have sub bags in them, so keep that in mind. All right, first thing I gotta do is sort out the resistors in here. Let's do it. Sorted out by value, so now it's time to plop them onto the PCB according to their position on there for the manual, and we'll solder them on. And for those that are new to this kind of thing, you can see the R17, R18, all that kind of stuff. Those are marks for resistors to put there. So if I look at the manual, I look at the R17 slot. It's a 1K resistor, and you probably won't be able to see it on camera, but the color code for that is brown, black, black, brown, brown. So I take that and I pop it into the R17 slot there. And then you just kind of snake the leads through, and you can kind of fold them. And that way everything will hold in there nicely until you're ready to solder it. So I'm still kind of a beginner with some of this stuff, but something new that I came across, at least new to me, was that this chunkier resistor here, which goes in R41, in the manual they recommend to, instead of placing it flush like all these resistors, to leave about an 1/8 inch gap off of the circuit board, so that way the airflow can kind of like be a little better around there, like underneath it. So I thought that was kind of interesting, and I'd point that out. So as you can see, I've got a little bit of an air gap in there, but everything else is mounted up tightly on there. I've got my soldering iron warming up outside of frame, so I'm going to double check that I put everything in the right spot, and we'll tack these bad boys on there. This is where the interactive build map really comes in handy. Since I've got the resistors on there, it covers up the writing. So if I want to double check that I've got the right thing in the right slot, I can go on to the site here, and let's look at R43. So I can click on that, and it'll populate the resistor in there with the color and everything, so I can kind of like double check myself as I go without having to, you know, pull any resistors out, and make sure everything looks good before I solder it in there permanently. I double checked all my placements on the build map and against the manual, and I'm feeling pretty good about it. So like I showed you earlier, I got all the backs folded down, so I'm feeling confident about soldering this. There are a few spots where I probably used a little bit too much solder. Everything came through on here, but you can see the spots where it's a little bit rounded off. So I'll keep that in mind going forward. I'll make sure to heat up the underside contact pads a little better, then use just a little bit less solder. But if you're brand new to this and you're not really sure, DIY Recording, they offer to send in pictures of your solder, and then they can give you feedback. So if you're new to it, or if you're just not sure how much or how little solder to use, that kind of stuff, send them a picture. They'll be very helpful. Next up, I've got two little diodes, D1 and D3 on the circuit board. And of course, got to make sure I line up the line on the diode with the line on the actual circuit board there, as you can see. So let's do that. Next, I got two small capacitors and a fuse. Pop those on there and solder it up. Next is 4 large capacitors, and the thing you got to look out for on this one is that there is a longer end and a shorter end, and the longer end is positive. Yeah, positive. So keep an eye out for that when you're putting this stuff together. Caps are on the board. Well, these four at least. You know the drill by now. Solder and trim. On we go. Seems a little on the early side, but now I'm gonna wire in the TRS jack for the DI. Next up, good old-fashioned LED. Like the capacitor, this one also has a long end, which is positive. And this will actually be going through the faceplate, so I'll have to be careful to line this up correctly. So for this LED, there is a little flat spot on the lead there, and you're supposed to pop this in until you hit the flat spot, then bend it out. So next, I'm gonna mount the faceplate to this per the manual. And what I'm gonna try and do is you basically wanna make sure the LED is flush with the faceplate, you know, so that's not sticking out or crooked or anything like that. Then you solder it with the faceplate on so that everything is locked into position. And then you take the faceplate off and kind of resume populating the circuit board. All right, I had to dig out a few parts here to get everything kind of lined up. So basically you gotta sort of halfway mount the PCB in the bracket with these two little screws here and kind of slide everything through. I temporarily attached the faceplate with the little washer there, but as you can see, that LED is nice and flush. Run my finger over it and it's real smooth. It's not poking through at all, and it should pretty much get the job done. So now that I've got that in position, I'll kind of disassemble everything and solder it exactly where it is. LED is soldered on, looking good. Next up, I got these switches. Solid. Real quick, I gotta show you guys how satisfying this sound is when you click the switch into the circuit board. Check this out. Oh, yeah. Nice. All right, now I've got some odds and ends like this relay, headers, sockets. I honestly don't know what those are for. Heatsink, that one's pretty self-explanatory. A couple transistors, stuff like that. And after this next round, apparently I'm good to power it up and actually give it a test. So I'm guessing I'll just kind of like half assemble it like I did for the LED and pop it into the 500 rack since I don't have the adapter. And I'll go through that in more detail in a minute, but yeah, so after this I'll hook it up and probe it with the multimeter, and I should be able to tell if all this is good so far. So that'll be exciting, unless I mess it up. Fingers crossed. All right, I've got another new challenge for me. Apparently this little header here needs to be exactly perpendicular with the circuit board there. So what the manual recommends is filling up one of those middle pads with solder while it's empty. And then if I understand this correctly, kind of like reheat the middle, and while that solder is still liquid, I kind of like push this up from underneath those little tabs there. And that way it'll kind of like snap into place so it doesn't rock around. I'll hold that there while it's all snapped in, take the soldering iron out, let it cool so that it's sort of like tacked into place, and then solder the rest of them as usual. Wish me luck, hopefully this works. All right, y'all, just for science, I'm gonna film this while I do it. Never tried this technique before, but I'm all about being transparent, so in case anybody else runs into this issue, or maybe you can learn something from me messing it up, which hopefully I will not do, but there's a first time for everything. So if you see right in the middle there, I've got the pad filled up with solder. So my iron is over there, it's nice and hot. So I'm gonna hold the iron to that, like I mentioned. get it liquefied, and then I'm gonna try and slide this up from underneath there while it's liquid, get it snapped, hold it there, take the heater off, and any luck, we'll be good to go. So I will try and keep you guys zoomed in for this. All right, I think I've got it lined up. Obviously it's not gonna go through because that is still solid solder. I'm gonna come at this left-handed. Here we go, come on. Oh, okay, clicked in. Let's see if it stays there if I let go. Okay. I think I pulled it off. There's not a lot of solder in there, but I did get a good solid snap when the solder did liquefy, so I'm thinking that did it. So now I'm thinking I'll just kind of like, you know, tack around it so I don't accidentally melt the one that set it in there in the first place. And actually before I do, just have a look at the other side, make sure it's okay. I mean, it seems to be on there pretty flat. Yeah, you know, we're gonna call this good. Let's zoom back out here and I'll power through the rest of these joints. All right, I'm at a pretty good spot here. Only thing left out of this first batch is I gotta assemble the heat sink and put that on there, then I'll be ready to power it up. So I think I'll do this, maybe take a little break, just to keep myself fresh, grab a drink. Oh, thunder outside. And then, yeah, we'll fire it up and hopefully this does not start smoking and lighting the place on fire. Real quick, I want to show you guys how this heat shrink assembly comes together. So this, heat sink rather, this heat sink separates and cools down these two transistors here. And the order that you want to assemble all this is first going to be this screw here. Then you've got that small plastic washer with the narrow end that actually goes in the transistor, so it lays flush like that. Then you've got this little insulation pad so that the metal on this transistor doesn't like short out against the heat sink and shorting out with each other. So you kind of pass the screw through that, get it lined up. Then get the heat sink, kind of assemble that in there. And you want, of course, the pins all facing the same direction. That insulator pad is a little oversized, but you know, as long as it's in there and there's not a metal on metal contact, it should be good. So then, with the screw still going, we're gonna put the next transistor in, metal side in. Then we've got our small black washer and this nut to seal all together. With this sort of loosely held together, according to the manual, I should plop this into the board. On the power section there, it's got the little area for it. And then, so I guess it goes this way with the screw head on the left side and then coming out towards the right. So I'll solder and then tighten everything up after that. All right, it is time for my first test. I got to plug this thing up into my 500 series rack. In the manual, they recommend there's like a little 500 extender cable kind of behind that multimeter you can see. Basically, I got to power it up and probe. I got to probe these spots here, making sure I'm getting 24 volts. And then I'm going to engage the phantom power switch, which is that one, I believe, and make sure the LED lights up. And if that looks good, then I'm okay to keep going. Just for funsies, I want to show you guys my testing rig here. I've got a mostly empty 10 slot 500 series. So I just popped the PCB in there with the power off, of course. Then I got my multimeter ready, set to 200 volts DC. So I'll fire this up. Nothing burning, that's good. So I'm looking for 24 volts on this, plus or minus 1 volt. In their example photo, they showed 24.7, black to the negative. This is really awkward with the camera. Perfect. 24/7, 24/6. Awesome, that's right where we want to be. Awesome. Okay, so now, that's the fan and power button. LED lights up. And that's it for the first test, so I'll power it down. All right. Next up, I've got the circuit for the DI, the direct input. And it's more or less the same, just with different components, of course. I got a bunch of resistors that I'll sort through, some transistors, a couple capacitors, a diode, and then a quick test at the end with REW. So I'm just gonna put on the time lapse for this stuff since it's more or less the same, you know, as far as like actually doing the soldering. But I will see you at the test and setting up REW and all that good stuff. Let's get it. That is the DI section all done. Every component in this little area here. So now I'm gonna go download REW and watch the YouTube manual on how to check this, make sure everything is good. So hang tight, I'm gonna go look into that. Basically what you do is you plug an output from your first output or monitor left on your interface into a TRS. And what you do is you send a 60 hertz at -10 dBFS or dB full scale. You send that out to this cable here, outputting from the interface, and then you take a reading on the voltage with your multimeter on that cable, and you use that to calibrate REW. So I'm going to set the frequency to 60. And I guess I don't need a dither. And that's going to be at -10 these decimals. Okay, and I'm just gonna make sure I match all their settings here. No dither, 60 -10 dBFS. Okay, so that should be outputting to this now. Now in REW, I'll hit play. And you may or may not be able to see, but I've got the signal coming out of just the left speaker out to this cable. Got the interface cranked up. I assume it's supposed to be at full volume. Multimeter set to AC voltage. Hopefully this meter can read this. It'll probably be a pretty low value. Okay, getting 2.0 exactly. With that 2.0 value, click on calibrate level. And that's 2.0. And I'm all calibrated. I switch to dBu. And I'm shooting for 60 hertz plus 4. So I'll change that. So now with that value going, I'm gonna plug my TRS into the DI input. So with that plugged in, I probe the 0V test point there and one on the DI. So I'm gonna have to go grab my 500 series rack and then get this thing plugged up and then try this test. But basically what I'll be doing is plugging that in with that value that I set in REW. And then there's the DI probe spot and 0 volt. And I'm looking for about 0.6 volts with this plugged in, sending that signal in there. Okay, got the chassis ready now. One thing I noticed is that in the written manual, it says to probe the DI and the 0 volt spot. But in the video that I watched, it actually shows the guy or girl probing the DI and the in. Now, maybe that's the same thing. I'm honestly not sure. But the in seems to trace to this stuff. And the 0 volt, this bottom one here doesn't seem to trace to anything. Oh no, wait. 0 volts on top. Well, I guess I'll just try both and we'll see what happens. It's on. Still set to AC volts. I can't see shit in there. All right, no reading there. Not sure what's up with that. We'll try DI and 0 volts. 0.3. All Okay, I think it said I should be getting 0.6. Let me go back to the drawing board. Maybe I'm hooking up something wrong. All right, I checked my work off camera and I'm getting 0.4, which I feel like is pretty close to 0.6, but I don't know, it's entirely possible that maybe I didn't set something up right in REW, or maybe because I've got other stuff plugged in, but I mean, that's pretty close. Also, the multimeter for AC voltage is out of 200. Maybe it's just not accurate down to that low of a voltage. So I'm just gonna roll with it and hope for the best. Now I'm on to section 3, also known as bag 3. And this is gonna be for the balanced input, and this is where stuff gets juicy because I'm gonna be putting in one of these transformers onto one of these subboards, and we'll be able to start actually getting this thing looking like a 1073. Let's dig into bag 3. So this little board wasn't anything particularly exotic. It just sort of acts as a header for the transformer, aka the juicy stuff. Look at this beauty. Oh, if it'll focus. There we go. Nice. So, all I do from here is I just kind of plop the board on and screw it in. I guess it goes somewhere on there. We'll figure it out. Starting to make some good headway. Got the transformer and header mounted all up to the board. So it's kind of actually starting to look like something now. Up next, I've got bag number 4, which is the gain subboard. And this has got a lot of resistors that will need to go on it. But the pièce de résistance of this one will be the gain knob. So that'll be pretty cool. Let's get into it. This one was a doozy to sort through all these. Lots of combinations of blacks and browns, which look really, really similar when they're that small. So I think I'll call this the end of part 1. I'm starting to get a little tired, and I noticed myself kind of putting some things in the wrong places. So let's call this part 1, and getting pretty far along here. So in part 2, I'll finish the build, and then maybe in part 3, I'll do some like sound demos and run some different stuff through it, like doing the bass DI, running some drums through it, of course vocals, all the classic 1073 stuff, keyboards, whatever we can think of really. So for now, I'll sign off and I'll see you in part 2.